Welcome to Module 6 of Versa Essentials, WAN Implementation. In this module, we'll discuss today's WAN implementation and its challenges, how SD-WAN is playing a key role in making the implementation process agile, and how it can deliver a true borderless networking experience to customers. WAN implementation is the process used to stage and deploy customer premise equipment and to enable WAN services for customers. The traditional CPE onboarding process has been a manual and time-consuming process. Even after proper design and planning, implementation is still considered to be a tedious process and prone to human errors. Once a service provider delivers a WAN link to a site, engineers have to configure the CPE devices manually and perform various performance tests. Engineers sometimes have to stay at the site and work for days in order to ensure that the CPE is functioning as expected for a customer. Manual device onboarding procedures are error-prone and require multiple peer reviews and authorization before the final configuration can be run on the appliance. This implementation approach lacks agility and isn't very cost-effective. Service providers and large customers have to manage large teams to take care of implementation, which has direct impact on operational expenses. Another important aspect of traditional WAN implementation is the dependency on the service providers. Service providers that provide MPLS-based VPN services have control over a customer's design and topology. Any change or update in the customer's current network topology or design has to be implemented by the service provider, which is again a time-consuming activity and very process-driven. With the widespread adoption of cloud-based consumption models like infrastructure as a service, software as a service, platform as a service, and other cloud-based services, the industry is facing another challenge of implementing cloud-based branches. While virtual network function or VNF implementation is well established over a cloud infrastructure, bootstrapping the VNFs is still a challenge. Even though the borderless network framework refers to sites that are connected over MPLS networks, the internet, LTE, and other network circuits, all of which converge together for the end customer, borderline networks are still distributed at the technology level. From a technology standpoint, the connections are different technologies. MPLS-based VPN, IPsec SSL VPN aggregators, private APN over mobile networks, and so forth are managed and implemented differently. This is another reason why traditional WAN implementations are slow and complicated. The SD-WAN implementation framework has a lot of focus on WAN implementation. It addresses how to automatically bootstrap the customer premises equipment with minimal to no manual intervention. The SD-WAN framework is focused on building a cloud IP platform which is underlay agnostic. This means that the SD-WAN implementation is agnostic to MPLS-based VPN links, LTE services, and so forth. Each of these WAN technologies is simply viewed as a physical transport medium to remote locations. The SD-WAN framework also includes an orchestrator component which can be programmed to bootstrap the CPE device automatically. Some of the approaches available today for CPE bootstrapping are using scripts to automate CPE provisioning, using URL tokens, zero-touch provisioning, and mobile app-based provisioning. In all of the above-mentioned approaches, the appliance will be automatically bootstrapped by the orchestrator. Let's discuss each of these approaches. Using scripts to automate CPE provisioning. This approach for CPE implementation is focused on using Python or other shell scripts to create a basic configuration on the appliance. This temporary configuration makes a request to the orchestrator to trigger the bootstrapping procedure. The engineer at the site has to manually trigger this script with inputs based on the implementation. The engineer is expected to know how to use the script and to change the parameters if required. This can be combined with two-factor authentication for additional integrity checks. URL token-based ZTP. With URL token-based ZTP, the engineer at the site uses a URL token instead of manually running a script. The URL token can be created by the orchestrator and doesn't need any manual inputs. All the engineer has to do is connect their host machine to the CPE device over a wired or wireless LAN and click on the URL token. The token has information about WAN links, IP addresses, and IKE parameters to securely connect with the orchestrator. The orchestrator can then bootstrap the appliance. If there is any change in the design or IP schema, the network administrator can provide a new URL token generated by the orchestrator to the site engineer. The engineer will then click on the new URL to start the bootstrapping process. This process doesn't require site engineers to understand any scripts or configuration. The site engineer or customer can connect over the LAN to the device and initiate the device onboarding process by simply clicking on a link. This can be combined with two-factor authentication also for additional integrity checks. The third approach towards simplifying device onboarding and implementation is zero-touch provisioning. With zero-touch provisioning, or ZTP, there's no need for an engineer at the customer side at all. The device onboarding process is completely automated with no human intervention. The customer edge device requires a WAN connection, and the bootstrapping will happen automatically. This approach requires a pre-staging infrastructure, and the device will have a pre-loaded factory configuration that will help in the zero-touch deployment. This can be bundled with two-factor authentication for additional integrity checks. Mobile app-based zero-touch provisioning. With mobile app-based ZTP, a customer can use a mobile application to start the bootstrapping process. A mobile device, such as a phone or tablet, can connect to the device over Bluetooth or Wi-Fi using a mobile application. The device can leverage the mobile device's internet connection to talk to the orchestrator, which can then bootstrap the device. Also, in various implementations, the mobile application can leverage URL-based provisioning of the appliance by using the Wi-Fi to talk to the appliance and the WAN links for provisioning. All of these techniques help reduce site turnup time and costs. SDWAN evolution is the main driver for the adoption of these techniques, and together these concepts help provide true borderless and agile WAN implementations. This is the end of Session 6 of the Versa Essentials series. In this session, we discussed traditional WAN implementation and its challenges, and SD-WAN implementation and its benefits. Thank you for your participation in this session, and we hope you found the session informative.